This should be an absolute breeze for us. Right triangle trigonometry. Who's our buddy for right triangle trigonometry? SOH. S stands for sine, C stands for cosine, T stands for tangent, correct? What do the O's and the A's stand for, and H's? Opposite, adjacent, and hypotenuse. So, just for a refresher, they've got a theta. You know, depending on who your math teacher was last year, if they used the theta or not. It's a Greek letter, just like alpha, beta, all this stuff, theta. You've got to figure out how these sides relate in relation to it. Isn't this side right here the one straight across from theta? That's the opposite side. Adjacent is basically the one that's touching it. People are like, hey man, both of these guys are touching theta. The red one and the blue one are both touching theta. Of course they are, but by God, you better know where the hypotenuse is of a right triangle. Where is the hypotenuse? It's always across from the 90. Cool? The only time you use SOH CAH TOA is when you have a right triangle. Before we get going, let's check to see if our calculator is in the correct mode. Because if it's not in the right mode, we're in bad news. So please type the sign of 30 and make sure you get back 0.5. If you do not get back 0.5, then I will show you how to change the mode in your calculator. If you have a graphing calculator, do you see this button right here that says mode? Press mode. And then there's two options right here for radians or degrees. Please change that to where that dude is highlighted over degrees and hit enter. And it should change it back to degrees for you. If you don't have a graphing calculator and you have a baby calculator, I can show you individually if you come see that. So double check now. To get out of there, you just quit. Maybe. Quit, and then sine of 30 equals 1/2, 4.5. Are we all good in the same mode here? That's why you put your lid on your calculator, so all those buttons don't get hit, you know, and it changes the mode out of that. Awesome. So the mnemonic device is SOH CAH TOA. We talked about that. Use the calculator to evaluate, round to the nearest hundredth. They want to know what the sine of 28 is. Well, by God, you just punch in the sine of 28. And they want you to round to the nearest hundredth. So let's do that. How many decimal places is that? 2. You must put approximate symbols since you are rounding this. It is approximately 0.47. Punch those other 3 in. Find the cosine of 62, the tangent of 50, and the sine of 62. Is this what we are getting? Interesting. Why do you feel that those came out to be the same? Let's see if we can take it to the trig level for FST people next year. 28 degrees and 62 degrees. Aren't those complementary angles? What does complementary mean? That they add up to be 90 degrees, right? The sine and cosine are inverse functions of each other. So like if you want the sine of 28, that's going to be opposite over hypotenuse, correct? Which would be whatever this number is over that guy. If you want the cosine of 62, isn't that the complement to that 28-degree angle in the exact same triangle? It's going to be adjacent over hypotenuse. Well, isn't the opposite leg the same thing as the adjacent leg when you're comparing the two different angles? It's the same thing over itself. These are inverses of each other, meaning if those numbers are complementary, you get the same thing back. Refer to the triangle at the right. Is it a right triangle? Yeah or no? They want the sine of theta. Remember our buddy SOH CAH TOA? It is still, you know, as much experience as I have, I write him on the top of the paper just so I don't confuse myself. This is too easy to get wrong. We must focus all of our attention around theta, and then let's do this. Which one's opposite, the 28, the 45, or the 53? Put a little OPP there. Yeah, you know me. Isn't this the adjacent? And this is the hypotenuse? They want two answers, is what we're going to put, exact and to the nearest thousandth. They don't want us to solve for theta. They want us to find the sine of theta, which is such an easy question that we get it wrong all the time. They just want it as a fraction. The sine is defined to be the opposite leg over the hypotenuse. Do you know how long the opposite leg is compared to theta? It's how long? 28 over the hypotenuse. How long is the hypotenuse? There it is. That is the sine of theta in this particular problem. The definition of sine is it is the ratio of the opposite guy over the hypotenuse. Can that fraction reduce? 28 over 53? We got to punch it in anyway because they want it to the nearest thousandth, right? So there it is. But how will I check to see if he reduces? Math, enter him. Did it reduce at all? Nope. So now approximate it to the nearest thousandth, approximately 0.5 to what? To 8? Y'all cool with that? Yes? No? Maybe? Cosine of theta. Theta hasn't moved. It's adjacent over hypotenuse. What is adjacent over hypotenuse going to be? 45 over 53, which is about, we got to punch that in, 45 divided by 53. Math enter him real quick just to see if that reduces. Did it reduce? So 0.8 for what? 9, and the tangent, opposite over adjacent. .28 over 45. About 0.622, since we're rounding to the nearest hundredth, thousandth, if I can speak correctly. Y'all good with that? So simple, right? What is the tangent of theta? Well, it's opposite over adjacent, 28 over 45. Cool? Refer to number 7. If you still have your geometer, you might want to dig that guy out because it'll be handy to start drawing shapes. Otherwise, we're going to have to sketch, and I'm not a big sketch fan. But I want you to sketch a right triangle. If you have your geometer, draw a right triangle. Angle B is acute. Angle B is acute, so that means it's not the right angle. I think they should have said angle A and angle B is acute. So let's give it a sketch. All right. So angle A and angle B are acute. That means C is the 90. Cool. Cosine of B is 3/7. What is the definition of cosine? Cosine is what? Adjacent over hypotenuse. So isn't this adjacent, and this is the hypotenuse? Are you with me on that? It's adjacent over hypotenuse. Adjacent to what? And adjacent to what? Like, what is this 3 adjacent to? Angle B, right? Because they're telling you the cosine of B. You know the hypotenuse is 7, because they're telling you that. And how long is the adjacent side to B? 3. Doesn't that go right here? Isn't that the dude? That's adjacent to 3. They're asking you to find little b. You should have some knowledge that if your triangle is big A, big B, big C, that little a, little b, and little c are across from those. If this is a big B, isn't little b right across from that dude right there? Hopefully you were taught that. So let's figure out B with the Pythagorean theorem. Why can we use the Pythagorean theorem? This is what kind of triangle? Which guy goes all by himself? The hypotenuse does. 3 squared is 9, b squared is b squared, and 7 squared is 49. B squared equals 40, so b equals the square root of 40. Can that simplify? You bet it can simplify it. So 4 goes in there, so this is really radical 4 times radical 10, which is 2 square roots of 10. Then I'm going to erase that little b to get out of my way and call that 2 square roots of 10. I don't care if you even put that little b there in the first place. I was just trying to explain it to you. But that is 2 square roots of 10. Find the tangent of big B. Tangent of B. Well, tangent of B will equal what over what? Opposite. What is opposite B? 2 square roots of 10 over adjacent, which is, can this fraction reduce at all? There's our answer. So what did we do? We sketched a right triangle because they told us a trigonometric ratio right here. Then we substituted in And we did the Pythagorean theorem to find that, and then we asked for that question. Yes, sir. Good question. Somebody asked if this should be plus or minus, because when we square root this, you will get plus or minus square root of 40. But since this is a geometry problem, you can't have a negative distance, so you throw the negatives out. It's an extraneous answer. Cool? Y'all good with that? Next, let's do it again. Draw that same right triangle, because they say angle A and angle B are acute. That means that angle C is the right angle. While you're drawing, you might as well draw it for the next problem also. So you can pause the video and get that done for me, por favor. Tangent of A is 7/12. Put a 7 in this picture, put a 12 in this picture, based on the definition of tangent. Tangent is opposite over adjacent. But what angle are we focusing our attention around? A. So opposite, 7, adjacent, 12. It doesn't matter if your picture doesn't look right to scale or anything like that. That's no big whoop. The numbers trump the picture. Let's find what's missing. Is it little a, little b, or little c? Which guy's missing? Little c, let me in. Not for the hell of much imagination. Da-da-da-da-da. 288, is that right? No? What is it? What? Way off. Samsonite. 193. So C equals the square root of 193. If that can simplify, we'd do it. It does not simplify. Put it in the picture. Picture pages, go and get your crayons and your pencils. Bill Cosby, early 80s. Yes. So, what do they want? Cosine of A. Cosine of A. Definition of cosine is what over what? Adjacent over hypotenuse. Which angle are we focusing our attention on, though? A, right? Adjacent is 12. Hypotenuse is? Are you satisfied with that answer? Not even satisfied. Can't have a radical in the denominator. So let's rationalize it. Multiply by the number 1 in a fancy form. What's the number 1 you want to multiply by? Radical 193 over radical 193. Just come down a line. Cosine of A will equal 12 square roots of 193 over, what's radical 193 times radical 193? 193. Do. Yeah! Do it again on the next problem. On the next problem, once you set it up, with the sine of b equaling 3/8, you should figure out that the side missing is the square root of 55. To find the tangent of b, you need opposite of, we're focusing on b, so 3 over adjacent, which is radical 55. Can't have a radical in the denominator, so we will, especially when they're wascally radicals. 3 square roots of 55 over what? 55. Make sure that these can't reduce either. Feel pretty cozy with those. That's hilarious. Next, even easier. Do you have a right triangle? Yes or no? Do you have an angle and some sides? It's SOH CAH TOA time. So focus your attention on the angle provided to you that is not 90. You never use the 90. And let's figure out which trig function we want to use. 10 is what in relation to that 38? Opposite. And x is adjacent. Which trig function will we be using? The tangent, make sure you say their names right. It's sine, cosine, and tangent. The tangent of the angle measure, which is how much? Equals opposite over adjacent, 10 over x. Trig function, angle measure, ratios definition. Cool? Trig function, angle measure equals ratio. Rock and roll. Let's solve for x. Where's x? Upstairs or downstairs? We don't like that. Let's get rid of this divide by x by multiplying both sides by x. So x times the tangent of 38 equals 10. Then we divide both sides by the tangent of 38. Realize there are no 38s in this number at all. It is the tangent of 38 that we need to divide by. So x equals 10 over the tangent of 38. And now we punch that in our calculator. 10 divided by the tangent of 38 and close the parentheses because it automatically puts that parentheses. And they ask us to round how? Nearest tenth, so about 12.8. Do they give us a unit to put it in? So just put about 12.8. Cool? Get an equation on 11, then check it with mine. It's a right triangle. They gave you an angle measure and a side length. If you have the right equation, solve that equation for x. Punch that in, round to the nearest tenth. Should it be more or less than 4? Well, you can use your reasoning skills. Should it be more or less than 4? It has to be more than 4 since this is the hypotenuse. 8.8, is that what you got approximately if this thing would ever work? 8.8. Sorry, video people. My pen is being a pain in the buns. 8.8. Cool. Next guy. What do they want you to find in this right triangle? Realize it is a right triangle. What do they want you to find? Side or angle? Angle. We need SOH CAH TOA to do it. So, which trig function would we use if this is the adjacent side to the angle we're looking for and 7 is the hypotenuse? Cosine of the angle measure, which is x, equals adjacent over hypotenuse. Correct? What we will do to find the x value when you don't know the angle measure is this is how it really works. You do this. Oh, goodness gracious. You take the cosine inverse of both sides, and what does an inverse and its function that is the inverse do to each other? They cancel each other out, right? So those are, you don't have to show this work. I'm just kind of showing you where it comes from now. The inverse cosine and the regular cosine multiply out to be 1. Is that right? That's what happens with inverses. So this is what we did back in the day. We just said make them switch places. The cosine inverse of 4/7 equals x. The 4/7 and the x just kind of do the old switcheroony, right? The inverse. To punch that in, those are right above your sine, cosine, and tangent buttons. Right? It's the little -1, and you should know by now that that's read out loud as inverse, right? So 4/7, just type in 4 divided by 7. And how do they want you to round that? So x is about 55.2. Label, since that's an angle measure, it is in degrees. When you don't know the angle measure, that's the only time you use the inverse. Do that on 13 for me. You do not know the angle measure, you should be using an inverse. Pause the video, get that done. You are dealing with opposite and hypotenuse, so that's the sine function. You don't know the angle measure, so you need the inverse sine of 4/10. If you want to reduce it, reduce it. If you want to leave it 4/10, leave it 4/10, because you're going to get a decimal back anyway. So there you go. Pretty good refresher of trigonometry. Agree? Now let's get into, I wouldn't say tougher problems, but tougher for your memory. Read, discuss. What do we need? We have figured out that all the sides of this hexagon are 12. Could you tell me why you know that? Regular. That's what regular means. So you don't need to put them all in, but those two will be valuable to us. Cool. What else do we know? Heard some other good whisperings. The triangle that we would probably be focusing our attention on is this triangle, triangle ABC. Is everyone pretty comfortable with that? Right? Okay. Any kind of problems approach you as of now You're all correct so far, but there's a problem. It's not a right triangle, meaning SOH CAH TOA isn't that helpful to us at the moment. Can we get a right triangle? Let's discuss what we know about triangle ABC. It is isosceles. I'm going to notice that there's an isosceles triangle here. I'm going to drop this in. What did I just draw? It is the height of that triangle. And if a pilot told you that you are flying at a height of 30,000 feet, what's another word that he might say instead of height? The altitude of this isosceles triangle is very, 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 very special. First of all, an altitude goes from a vertex perpendicular to the opposite side. Perpendicular means at a 90. But the altitude of of an isosceles triangle from the vertex does something to that base right there. It perpendicularly bisects it. So, okay, this is x and this is x, if you will, right? There's two equal pieces, right? Can we do Pythagorean theorem? No. Can we use trigonometry? It is true that we do now have right triangles involved. Little red right triangle. And the other one's congruent to it, right? They're exactly the same. Can we use trigonometry on that little red right triangle? Yet. What's missing? I need either this length right here, the altitude, or something else to do trigonometry. What was provided for us to do trigonometry in right triangles? An angle measure. Tell me, regular, if you just say all the sides are the same, that's called equilateral. Right? What else is true about regular polygons? All the angles are the same. So by God, wouldn't it be awesome to know what all the angles added up to in a hexagon that's convex? Wouldn't that be awesome? Man, if there was only a formula to figure out the sum of the angles in any convex polygon. Oh, cool. How about this? Number of sides minus 2 times number of sides minus 2 times 180. So this is a hexagon which has how many sides? 6 minus 2, which is 4 times 180. Punch that in. I would hope that you get 720 degrees total inside of that hexagon. Any convex hexagon has a total of 720 degrees. This is not your average convex hexagon. It's what? And you told me that meant that all the angles are the same, correct? Well, how many angles are there in that hexagon? I would hope that there'd be 6 sides, 6 angles. And if 720 degrees possible and it's split up 6 equal ways, what do you do to 720? Divide by 6. What'd you get? 120 degrees for each one of those angles. Formula, I hope you write this down. One angle of a regular polygon. To find the measure of one angle of a regular polygon, you take the number of sides minus 2 times 180, then you take that result divided by the number of sides that you had. N minus 2 times 180 all over n. So didn't we get that to turn out to be 4 times 180 over 6, which equaled 120 degrees? Cool. So every single one of these guys is 120 degrees. This is the altitude of an isosceles triangle. Isn't this entire angle right here 120 degrees? What does that altitude also do to that triangle? It is the symmetry line. So how much is that angle in here? 60 degrees and 60 degrees. If that picture gets too small for you, you can now sketch this for me. Just sketch your own off to the side. Don't you have 60 degrees, 60 degrees, and a 12 right here, and you're looking for x? Find x. Centimeters. So I did the sine of 60. Oh, God, I feel like I stabbed myself in the back when I did that problem. I can't stand to do that problem that way. I just stabbed myself in the back. Because I'm a geometry teacher, and I just typed in the sine of 60. Did you hear that? That's what happens when you stab yourself in the back. I would never type in a trig function with the number 30 or 60 or 45. Why not? 30, 60, 90 right triangles and 45, 45, 90 right triangles are special. This is the long leg of a 30, 60, 90 right triangle. This is the 30. Isn't he the short leg right here? How long is that guy? 6. 6. Then how does this relate to it? Take the short leg times the square root of 2 or 3. Square root of 2 or 3. Square root of 3, because doesn't 30, 60, 90 start with a 3? This is 6 square roots of 3. This is 6 square roots of 3. Total, 12 square roots of 3. Just for fun, punch in 12 square roots of 3. I'll bet you get the same stinking thing. Isn't that amazing? But I asked the boss, what do you want on this? She said she didn't care. I care. You know, I want you to succeed on that ACT, and that would have taken way less time, if you know that, to realize it's 12 square roots of 3 and just punch that into calculator. If you see 30, 60, 90, or 45, 45, 90 right triangles, realize there's a shortcut. If you don't know that shortcut, come ask me, and I will show you. Otherwise, this will work for you. But realize you're selling yourself short on that timed ACT that you have to take. You know what I mean? You're wasting time. Next, get that bad boy done. You and a pal work together. In a real life problem, we make basic assumptions that this, which is called what? The ground, and all trees or buildings or anything, we assume that they are what? Perpendicular, which that is not always the case, especially if there's a hill, you know, in that situation. So we have a right triangle situation. You all good with that dude right there being a right triangle? We knew that angle of elevation. You know why that's an angle of an elevation? Because which way did Juanita look? She looked up, right? Where did she look up from? That horizontal right there where she normally looks straight ahead. 62 degrees. If I find x right there using tangent, because that's opposite, and this is the adjacent side to it, right? I got 65.8 feet. Is that the answer to this question? Isn't this the right triangle that you just used right here? And you found x, which is this distance, correct? How tall is the building? So is x 70.8 feet? X is not 70.8 feet. X is 65.8 feet. But you must add 5, and the building is about 70.8 feet tall. Because realize this little nugget, new color, is not a part of X at all, right? That's that extra 5 feet that her eyes were off the ground. Should have been pretty comfy with that, especially when the picture was drawn for you. Eventually we'll have to draw our own picture. Yay for picture drawing. Last problem, the toughest of them all. Read to yourself. Let's see how confused we get. These have been the biggest struggle in this trig unit in Algebra 2, all because we can't draw the picture correctly. I want us to learn to draw the picture correctly. Are they giving you directions like on a map or on a compass? Yes or no? Start by drawing a compass rose, which is this. Bad. We want to draw this with this and solid segment and black. Do you know the 4 basic directions? What are they? North goes here. Never eat soggy Wheaties is what they taught me in elementary school. What did they teach you? Sour watermelon. I love sour watermelon. No. Never eat whatever, right? Never eat soggy Wheaties is what they told me. But north, east, south, west. Sound cool? Never eat sour watermelon, whatever. A ship. Here's where the ship started from. Cool? It sailed 59 kilometers on a bearing of 25 degrees. That means that when the ship just starts traveling with no arrows, it's going to make a 25-degree angle right in there. Cool? And here's a cool ship for you. There's our awesome ship right there. It sailed on a bearing of 25 degrees. How far did it sail? 59 kilometers. Everybody down with that? From where it started to where it currently is right now, 59 kilometers. Good deal? How far north and east of its original position is the ship? Well, all we need to do is do this. Connect. That. And what angle is formed right there, my friends? Right angle. Let's just make up variables for this. Let's call it x and y. You can call them whatever you really want to, but I'm using x and y. They want us to find both of them. Which variable, x or y, represents how far north this puppy moved? X. Isn't this going straight up north, right? So let's do this. North. Here's how far north he moved. We have a right triangle, don't we know an angle measure, and a side length. Trigonometry. So I'm looking for x. How is x related to the 25? Is he opposite, adjacent, or hypotenuse? Adjacent, and the side I have is 59, which is the hypotenuse, according to SOH CAH TOA. Which trig function are we using? Cosine of the angle measure equals adjacent over hypotenuse. Solve for x. Should it be more or less than 59? It's got to be less. That's the hypotenuse. 50 what? 3 to the nearest tenth? 0.5? Label? Kilometers. That was how far north it has traveled. Cool. Now east. Which variable are you looking for when you want to see east? Find y with trigonometry. Go for it. Still focusing your attention around the 25. Don't use this nasty number. You know, it's like you could, but use the 59. He's a nice, neat number. So that's opposite in hypotenuse. That's my sign. Da 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 da. 24 point what? Kilometers. You'll never guess what happened once they got there. You'll never guess. Arg. Go to ye next slide. You'll never guess what happened to this ship once they got there. Arg. Go to ye next slide. Take a guess. What? They found the treasure? Not at all. They were attacked by, and the ship was taken over by pirates. As you can see right there, it became a pirate ship. Awesome. Thank you, SOH CAH TOA, for all your help today. Tangent. We're going to draw our own pictures. Straight edge. Let me pass them out if you don't have them. The only hard part about these problems is drawing the picture. Once you have the picture drawn, I mean, it's just SOH CAH TOA. A ramp is to be built up to a doorway. Its slope is to be 1/13. And people don't know what that 1/13 is all about. I hope mathematically you understand what that word means. Have you seen that in a math class before? And if you was to have a slope of 1/13 on a graph, how would you graph it? You would do what? Rise over run, right? So rise over run, correct? Here's the ground. That's where you should really start your drawing at, the ground. And what they want this ramp to do is, here's the ramp in green. Doesn't a ramp go up, correct? For every 1 foot of rise, let me get my other straight edge here for a second. For like, when you rise 1 unit, whatever it is, do they tell us a label? They don't, you know. Should most likely be 1 foot right there. Like if they did 1 foot of rise, then they should have 13 feet of run. Cool? Which one's the run? The green one or the red one? Is that what you do on a graph? You'd do this, rise 1, run 13 obliquely. You'd run 13 obliquely. How do you run? Horizontally, correct? You know, so if this is your rise, then this is your run of 13. Cool? What are they asking? What angle does the ramp make with the horizontal? I'll give you a little multiple choice. Little a, little b, or little c. Which one are we looking for? The angle that the ramp makes with the horizontal. Little c. So here's what we need. We definitely need this in our picture. Ba-boom. And then let's put a theta in there. Because the angle we're looking for is this, so we'll call it theta. This is a right triangle. You want to use Pythagorean theorem? It's a right triangle. I got 2 sides. You want to use Pythagorean theorem? What would Pythagorean theorem get us? The length of the ramp, the hypotenuse. Do we want that? We want the angle that it makes. So since we're dealing with right triangles and we have angles involved, it's our buddy SOH CAH TOA. Which trig function are we using? Tell me what it's called. What's it called? Tangent of what? Equals 1/13, right? Opposite over adjacent. And then the tangent inverse of 1/13 equals theta. And then tangent inverse of 1/13. Oh yeah. What did they tell us? Around 2/10? About 4 point what? So theta is about 4.4 what? That should make sense. I hope you've seen a ramp before. I hope you realize that ramps are designed mostly for wheelchairs, you know, and there's no way that a wheelchair should climb a ramp that is that steep. You know what I mean? It should be very gradual, right? Very, very gradual. Small angle. Cool? Think about it. Next. The picture is drawn for you. But man, oh man, oh man, oh man, do we have a hard time with these pictures. Let's understand the picture because it's not drawn for you on your homework. A plane is flying at 31,000 feet. Isn't that the height of the plane? Right? So that's perpendicular from the ground. Its descent, please tell me what the word descent means to you. The plane's going to go down, but down from where? Down from this. Isn't this the plane's normal line of flight right there? He was flying horizontally. He must go down from that to land at an angle of what they're calling theta in this case. Cool? Down from that. Angle of depression. If he needs to start going down right here, and the airport's right here, which they say is 125 miles away from where he was, cool, it says find the angle of depression. Well, this is not even in our right triangle, but based on what we did earlier, tell me why this is also theta. These are parallel to, boy, I'm having a hard time. These are parallel to each other, and those are alternate interior angles. So this, my friends, the red theta is not an angle of depression, though. Why is it not an angle of depression? It doesn't go down from a horizontal. You must realize that this is the angle that the plane starts to move down at. So go for it. Pause the video, give it a shot, better check back when you're done, video people. What we have discovered is that these are not in the same units. So I'm going to change this into feet by taking that 125 times 5,280. Getting a big old 6,6 with 4 zeros. Is that right? 1, 2, 3. Is that 4 zeros? Go back and put in a comma. And then I can do the tangent of theta to equal opposite over adjacent, 31,000 over 660,000. You don't have to reduce if you don't want to, but I'm going to say peace out to you, zeros right there. No need to punch all those zeros in when I want to retype. The tangent inverse of 31 over 660 equals theta. And I hope I get a small number because that's how the plane's going down at. I don't want that plane to crash and kill me by going down so fast. I want it to go slowly of 31 over 660. Struggling. About what to the nearest tenth? That sounds like a smooth landing to me, right there. Groovy? One more. Wop, 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 wop. Talk me through it. What do you need to find first? Same problem we did last time with a different polygon. What do you need to find first? The measure of the sum of the total, right? Find me the total measure in this decagon. How many sides does it have? Boy, if you don't know, I bet you could count them. How many sides does a decagon have? 10. This will tell you the total degrees, number of sides minus 2 times 180. But then aren't there 10 angles because this is a regular decagon, correct? So to find the measure of one angle, we just divide it by 10 again. So 8 times 180 over 10. What'd y'all get? 144 degrees is the measure of one of those angles. Awesome-o? It is also the measure of this angle right here. This picture is too tiny for me to want to deal with. Please sketch a new picture of triangle REG. And we just figured out that that measured 144 degrees. And each side is 10 inches. Is that what it said? What kind of triangle is that? Can we use SOH CAH TOA on him right now? Why can't we use SOH CAH TOA? It's not a right triangle. What kind of triangle is that? Isosceles, because it has, tell me the definition of an isosceles triangle. Not two equal sides, at least two equal sides. And when you drop this in, tell me what this is. The altitude of an isosceles triangle from the vertex, it does something special to this base right here. It perpendicularly bisects it. So if this is x, shouldn't that be x? Not only does that altitude perpendicularly bisect the base, it is also the symmetry line for that isosceles triangle. And if that vertex angle was 144 degrees, it bisects that as well to where this is 70 deuce degrees and that is 70 deuce degrees. Cool? Can we use SOH CAH TOA? Meow. Find x. We've got this nugget for a right triangle. This is opposite. This is the hypotenuse. So the sine of 70 deuce equals x over 10. 10 sines of 72 equals x. Instead of typing in 10 sines of 72, because all that's going to give you is this little x right here, what do you need to do to that when you're all said and done? Double it. So why don't you just type in 20 sines of 72 instead of 10 sines of 72? Sound cool? Because we need it times 2, so that'd be 20 sines of 72. But that's not what x equals anymore. 20 sines of 72. About 19 points, they say hundredths, so that's 19 point what? Do they give us a label? And it's about. Fabulous?